Our next question is page 215, number 7. In this question, we're talking about the manager of a hockey arena pricing tickets for an upcoming game. Now, the equation given for the revenue that this manager can expect to receive is R equals negative 100 times P minus 15 quantity squared plus 22,500. And this question would seem to suggest that the relationship between price of a ticket and the revenue or money received by the arena owner would be quadratic. And this might not make sense at first, but if you think more about it, it really does. Imagine if the price of a ticket was 0. Well, if the price of a ticket was 0, then the revenue that the manager would receive would be 0, because a lot of people would show up to the game, but they wouldn't pay any money to get in, so no money would be made. Now, as the price started to increase, less people would show up to the game, of course, but you'd be making more money. And so our revenue, the amount we received, would go up and up and up. But there would come a point where the price became so high that any more would actually start decreasing the amount of money that you received. For instance, imagine if the Spitfires charged $100 per game. Not a lot of people would go to the game, or at least not as many as go now, and probably their revenue would start to decrease. Well, that's what happens in this situation too. At a certain point, the price of a ticket becomes so high that the hockey arena managers actually become a little bit too greedy, and the revenue received decreases. This is another example of a quadratic relationship, and the graph of that looks like an upside down parabola. So our question asks us in part A to create a table of values. So we create a table of values like this, and we say, well, what if we charge $0? How much can we expect to receive? Or $5, $10, $15, $20, $25, $30. We're not going to charge much more than $30 for a hockey game. It's not the NHL. So we then look up how much it's going to benefit them if they start increasing the price. So the first thing we do is we sub in a 0 for P to see what the R value would be. So we let P equal 0. And if we let P equal 0, we see that R is going to equal negative 100 times 0 minus 15 squared. That bracket will be evaluated to be negative 15. The exponent is then done next. And negative 15 times negative 15 is 225. 225 times negative 100 is negative 22,500. And when we add that to positive 22,500, we get a revenue of 0. So we let P be the first possible number in our table of values, and we determine what R equals. So we put it in, 0 and 0. Then, of course, we let P equal 5, which is the next number in our table of values. Well, we sub in 5 for P, and we evaluate our bracket, and then we square that number, and we multiply, and then we add, and we see that if we let P be 5, in other words, the price of a ticket be $5, we'll make more money. We'll make $12,500. We put that into our table of values. Okay. We then let P equal 10. And when P equals 10, R is negative 100 times 10 minus 15, quantity squared. And that bracket evaluates to negative 5 and becomes 25 after we apply the exponent to it. Then we multiply, and finally we add. And we see that when the price is $10, it might be true that less people show up, but the company is making more money. Moving on. We let P be 15. Now, are we starting to get too greedy? Well, let's find out. We plug in 15 for P, and we get that our bracket equals 0. We apply our exponent, 0 times 0 is 0. We multiply, and we end up with a revenue of $22,500. So we can increase the price all the way up to $15, and we'll see that our revenue will still continue to increase. Well, at a certain point, they're going to have to start losing money by getting too greedy. And this is where it happens, when P equals 20. When the ticket price is $20, we get negative 100 times 5 quantity squared. 5 times 5 is 25. When we multiply that by negative 100, we get negative 2,500 plus 22,500, and we get $20,000 for our revenue. So we see that the manager of the arena just overshot how much the price should be. Well, we're going to keep going just to really make the point. If the ticket price is $25, of course, less people are going to show up. So the revenue, following our same steps as before, is only going to be $12,500. And last but not least, we'll let the ticket price be $30. What would then happen? Well, when 30 was plugged in for P, we would get a bracket value of 15. And then when we applied the exponent, we would get negative 22,500 plus 22,500. We would get a revenue of 0. In other words, what's happening here is when they charge $30 to get into the hockey game, 0 people show up. So while the ticket price is high, they're not making any money. So we come over here, and when 30 is our price, our revenue is 0. Then, for part B of the question, it says, what is the vertex of the parabola, and what do the coordinates of the vertex represent? Well, in this case, the vertex of the parabola, as we saw from our table of values, was 15, 22,500. Now remember, the x value, the letter that was in the position of x, was P. And the y value, the letter in the position of the dependent variable, was R. And this tells us that when the price is 15, our parabola reaches its maximum value of 22,500. So if you're running a hockey arena, that tells you charge $15 per person and you will make $22,500 in revenue.